Hello. Today I wanted to take a few minutes to talk about unit conversions. Unit conversions are frequently necessary when performing calculations in scientific fields. We often have measurements in one unit but desire them in another. When making conversions, it is a lot easier if you are familiar with some common conversion factors. Now, in terms of Chem 1211, a lot of these common conversion factors are provided for you. For example, all the conversions between metric and English or within the English system you see on the screen in front of you would be given on an exam or a quiz. The conversions within the metric system generally are not provided. More specifically, if the conversion involves a metric prefix between milli and kilo, those conversions are not provided. However, other conversions with smaller or larger metric prefixes, such as those for nano, pico, giga, and tera, would be provided. The common ones shown on the screen in front of you, however, would not. You are responsible for knowing those metric conversions. A reminder that when dealing with conversions, those conversions within one measuring system are considered exact numbers. Those between two different measuring systems, i.e. between metric and English, are not exact numbers and must be treated accordingly when we deal with the significant figures for a final answer to a conversion calculation. We can write conversion factors from each of the equalities you saw on the previous screen. One such example is 1 mile equals 5,280 feet. This conversion, or equality, can generate two conversion factors. The first is 1 mile over 5,280 feet, which is read 1 mile per 5,280 feet. The second is 5,280 feet per 1 mile. You can also generate conversion factors from text within a problem. For example, in a problem you might see a statement that says the car was traveling 20 meters per second. This means you can generate two conversion factors, 20 meters per 1 second or 1 second per 20 meters. Which conversion factor you use or need will depend on the specific question posed by the problem. We'll look at some examples shortly. One other very common conversion factor can be interpreted from a percentage. A percentage is always number of items per 100 items. For example, perhaps you are told that you are 23% body fat by mass. This really means that you have 23 grams of body fat per 100 grams of body mass, or another unit you could use, similar mass unit, 23 kilograms of body fat per 100 kilograms of body mass. Either of those statements will generate two conversion factors. The four conversion factors are shown on the screen in front of you. The top two are reflected from statement 1, 23 kilograms of body fat per 100 grams of body mass, and the bottom two are statement 2 involving kilograms instead of grams. However you generate the conversion factor, whether it's from a percent, the text in the problem, or a known equality, those conversion factors can be used to help you convert from one unit to another. The process by which we convert units is known as dimensional analysis. In that process, you are going to start with some given unit. You will perform one or more conversions using a conversion factor, with the ultimate goal being to obtain some desired unit. Now, the number of steps you have to perform, or number of conversions or conversion factors you have to use, depends on the problem and the plan you use to get from the given to the desired unit. Again, we'll look at some examples in a minute. Regardless of the number of steps that you use, when you arrange your problem, you will always begin with the given unit. When you write your conversion factor, the portion of that conversion factor that represents the given unit will go on the bottom so that the given units cancel. The portion of the conversion factor that represents the desired unit will go on the top, keeping in mind that that desired unit may simply move you closer to your ultimate goal and that more than one step may be necessary to reach the ultimate final answer. This is probably best illustrated by a couple of examples. Before I show you those few examples, however, I want to point out that doing conversions is often a process that is unique to each individual and each problem. I may perform conversions one way based on my knowledge. However, someone else may perform it a different way if they are aware of a different equality that I don't know. There is no, quote, right or wrong way to do a conversion problem. However, we should all end up at the same desired final answer. Let's look at some examples. Perhaps we run across this problem which says a student is 74 inches tall. How tall is the student in meters? I always like to take a moment and write out what I was given from the problem and what I need to find. In the case of this problem, you note that I have written down I was given 74 inches and that I was asked to find that height or length in meters. Second thing I do is develop a plan. In this case, my plan involves two steps. I'm going to convert inches to centimeters, and I'm going to convert centimeters then to meters. You'll notice that in each case, I have listed the equality between the two quantities in the steps for my plan. For step 1, I have noted that there are 2.54 centimeters in 1 inch. And for step 2, I have noted that there are 100 centimeters in 1 meter. Now I'm ready to carry out my calculation. My calculation begins with 74 inches. If you prefer, you may write 74 over 1, but it should be noted here that the 74 is found in the numerator or top portion of every fraction. You'll notice that we are enacting step 1 when we multiply the 74 inches by 2.54 centimeters, which is our desired unit for step 1, over 1 inch. The inches cancel. That's the given unit being removed in step 1. In step 2, our desired unit is to get to meters, so we put 1 meter in the top of our conversion factor. We want to get rid of the given unit, which is 100 centimeters, so that goes in the bottom of our conversion factor, and centimeters cancel. If you multiply this out, taking 74 times 2.54 times 1, and then dividing that entire product by 1 times 100, you get 1.9 meters. It's also worth noting that both conversions, by definition, in this case, are exact. So we started with 74 inches, which has two significant figures. We did multiplication and division with two exact numbers. We end up with a number 1.9 meters that has two significant figures. Let's look at a little bit more complicated example. Our second example involves plant fertilizer. Plant fertilizer is 15% by mass nitrogen, which is N. The question is, how many grams of nitrogen are in a container that holds 10.0 ounces of fertilizer? The givens in this case are that fertilizer is 15% by mass N, and that we start with 10.0 ounces of fertilizer. We need to find the grams of nitrogen. Our plan in this case is going to involve 3 steps. Number 1, we're going to convert ounces to pounds. I note here that there are 16 ounces in 1 pound. If you didn't know this, you could look it up in your textbook or on the internet. Second step, convert pounds to grams. I note that there are 454 grams in 1 pound. Third step, convert grams of fertilizer, which you have from step 2, into grams of nitrogen by utilizing the percentage, which can be interpreted as 15 grams of nitrogen per 100 grams of fertilizer, as it is 15% by mass. We're now ready to carry out our calculation. Again, we begin with the 10 ounces of fertilizer. We perform step 1, and in step 1 our desired unit is pounds. 1 pound goes on top. We were given ounces. We wish to get rid of those. They go on the bottom. Step 2, we place 454 grams on top as our desired outcome from step 2 is grams. Place 1 pound on the bottom so that the pounds cancel. Finally, in step 3, we have grams of fertilizer. We want to get rid of grams of fertilizer, and we want to get our desired unit, which is grams of nitrogen. We place the 15.0 grams of nitrogen in the numerator or on top. Place the 100 grams of fertilizer on the bottom. Grams of fertilizer cancels, and if you perform this calculation, you'll end up with 42.6 grams of nitrogen. Noting this time we have some conversions that are not exact numbers. The 10.0 grams of fertilizer has 3 significant figures. The 16 ounces in 1 pound is an exact number within the same measuring system. However, 454 grams per 1 pound is a conversion between metric and English. It is not an exact number. We ignore the 1 pound. We treat that as exact. 454, however, has 3 significant figures, the same as what we started with in our 10 ounces. So right now it appears we should have 3 significant figures in our answer. The 15.0% is also not an exact number, but it also has 3 significant figures, and therefore our answer is going to have 3 significant figures, 42.6 grams of nitrogen being the correct answer. It's worth pointing out that in the percentage you do treat the 100 grams as an exact number. Let's look at one final example. And that is an example where we have cubic units. We will often have to convert from one volume or cubic unit to another. It's important that we understand that this is a little bit different than the standard unit conversions we've looked at so far. The reason it is different is because you will actually have to cube your conversion factor before utilizing it in your calculation. Let's say we wanted to calculate how many cubic centimeters there are in 2.5 cubic inches. We know that 1 inch equals 2.54 centimeters. However, we want to get from 1 cubic inch to 1 cubic centimeter. We must cube the conversion factor, raising all items in that equality to the power of 3. Well, 1 cubed is simply 1, inches cubed is inches to the third, 2.54 cubed, if you put it in your calculator, is 16.4, and centimeters cubed is centimeters cubed. In other words, 1 inch cubed equals 16.4 centimeters cubed. Now that we have that conversion factor, we can carry out our calculation. We begin with 2.5 inches cubed. We place 1 inch cubed on the bottom of our conversion factor and 16.4 centimeters cubed on the top of our conversion factor. 2.5 times 16.4 divided by 1 is 41 cubic centimeters, which is rounded to 2 significant figures since 2.5 has 2 significant figures and we are dividing and multiplying. I hope this provides you a little bit of insight into how to convert units within chemistry and science in general. Unit conversion problems are a lot like riding a bike. The first time you may fall off. Persistence, however, will develop a natural progression of steps which will allow you to be successful in all future problems. In other words, practice makes perfect. Feel free to consult your instructor or textbook if you need further assistance with converting units.